PicoSure technology is a very new technology. So this difference to old-time lasers is that we have extremely short pulses. It was a revolutionary technology that we got some years ago in our office. The difference to the old-fashioned lasers is that the energy that is applied to the skin is compressed to the extremely short time. When we got the first lasers in this class, it was the PicoSure from the company of Cynosure in our hands. We normally only treat tattoos with it. And in the case of tattoos, it was a revolution that we was able to treat blue and green, not only black. Now, the first time we was able to treat sufficiently blue and green. And the difference between an old-fashioned laser, let's say a nano or a millisecond laser, to this PicoSure laser is the short, extremely short pulse. So we drive the laser impact in the skin from the so-called thermal confinement to a stress confinement. To explain this, what we do is that we ultra-shortly heat up a structure within the skin, expand the structures, take the energy away, and then we put stress on the structure and it breaks. Comparable to a situation that we have if we have ice water and we would throw into this ice water hot glass and it will directly break. So fast temperature changes on crystal structures will cause a break of the structure. This is true for the tattoo particle. This is implemented into the skin, like black, it's carbon black. It's like a little bubble inside. Or the crystals that we use to cause colors in the skin. It's crystal structures. This is three-dimensional, orientated within the skin, breaks the light, and then we have a color within the skin. This structure can also be braked, comparable to that what we see when we change the temperature within glass very fast. Interestingly, we have the same situation with human pigment. Human pigment, the melanin, is, when we look on the structure, the chemical structure, also a three-dimensional structure when it forms huger molecules. And if we ultra-short heat this up, we break the structure comparable to that what we do with tattoos. And perfectly to do this is 755 nanometers, much more perfect than other wavelengths, as 755 nanometers only hits the melanin. Other wavelengths like 1064 or 532 also hits parts of their vessels and cause more side effects. So 755 is perfect for this. Nowadays we use this energy to make a skin renovation, tighten skin, get rid of scars, to change the skin itself. How we do this? So we know that we have a very, very special effect within the skin if we treat the skin with these extremely high energies. So as I said before, we compress the energy to ultra-short pulses. We talk here about gigawatts, really gigawatts. And these are working only over picoseconds, but it's a gigawatt. And gigawatts, for example, are good enough to illuminate Paris, the area where I'm coming from, or London. So it's the energy of an atomic plant with a very short time, with a very short impact time. And when we controlled the impact during our tattoo studies, we saw always some Switzerland cheese reactions within the epidermis. Nowadays we learned that it is an effect that we cause due to is directly affected by this extremely high energy. It's due to the high energy. So now we call this effect laser-induced optical breakdown. What happens? If we hit the melanin, we throw out one electron from the molecule, and this causes an avalanche process within the skin. What happens is that we get, in this avalanche process of a lot of molecules that hit other molecules, we get a plasma effect. So we have more or less cold plasma. And this ends up with shock waves to the depth and with directly biochemical signaling to the deeper areas. And this again causes removal of, let's say, wrong collagen, so we get a reunivation effect. So the fibroblast is forced to form new collagen and new elastic fibers, as well as it's forced to remove the old, scar collagen fibers. And this effect is now used to use the picosecond lasers for skin reunivation. And as I said before, perfectly is the 7055 nanometers wavelengths. To be more effective, the engineers developed focusing lenses. So like the other lenses that we had for other lasers as well, now we are focusing with a lot of focusing points the energy that we get out from the PicoSure lasers on the skin. Like pin, 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 impact zone, impact zone, impact zone. And then we get much higher energy and much more chances to cause this LIOB, laser induced optical breakdown procedures within the skin. This causes again shock waves, and this ends up then with skin renovation. So if we treat with the skin renovation effects that the picosecond technology, the PicoSure lasers provides us, we cause some redness. But this redness is normally not longer than 24 hours. In very worst cases, maybe a bit longer, some hours longer, but normally maximum 24 hours. Most of the patients have more or less nothing. They have a swelling for maybe 1 or 2 hours, and that's it. If they are home getting off of the office, they are fine. As we going after the pigment within the skin to cause this LIOB effects, the patients should stay away from the sun for a week or 2 or so, but that's good enough. The treatments taking place apart 4 weeks to 4 weeks in our office. That is our treatment systematics, that we take in the patients every second to fourth week to treat him for this skin renovation effects. The effect of the laser is a very short impact, and I compare the picosecond technology with our finger that we put on an iron. The finger on the iron, nothing happens. You are burned. So we make it ultra short, and there is no pain normally. It's a little bit discomfort, but no real pain when you treat with the naked lens or with the so-called focus lens. Discomfort, no pain.